Okay. For the final panel of the day, I'd like to welcome again my co-founder Alex Watson and Aditya from AWS, who works on their deep learning and large language models. This should be a very exciting conversation. I got a glimpse of their preview, and I think you're all in for a treat. So please enjoy, and hope to see you all soon.
Hey, I'm Alex Watson. I'm a co-founder at Gretel AI. I'm super excited to be here at Synthesize 23. Today, joining me is Aditya Bindal from AWS. Aditya, you want to do a quick introduction?
Sure. Thanks, Alex. Really excited to be here at the first step of Synthesize. So my name is Aditya, and I work on deep learning at AWS. A lot of the focus these days is on large-scale training, inference, compilers, and how all of these different technologies are enabling generative AI. So super excited to be here. Thanks for having me.
Most definitely. Today, we're going to cover a series of topics. Overall subject is really how LLMs can generate value for organizations. But diving into that topic, we're going to go anywhere from AI value creation to diving in on LLMs and things that we see happening in the developer and machine learning space around LLMs, and then also how to make generative models work at scale. So how do you make them work for your organization? How do you use to unlock your data? So super excited. I think right now, I think coming from the unique lens and perspective that you have at AWS, really excited to hear some of your opinions on these. Let's go ahead and dive in. Like maybe at just the highest level, and the question that we hear all the time from users on our platform and on our community is just saying, like, given all this incredible interest around generative AI, you have ChatGPT, you have Stable Diffusion and Dolly, and all these cool things that we've all played with and started to use. Where do you see the value for organizations being unlocked, maybe over the next year?
It's a great question. I think we've seen a lot of interesting proof of concepts and experiments where people have been able to do just amazing things with text to image models and text generation models. And we're starting to see some applications among enterprise customers where they take these building blocks and they try and build some end-to-end applications out of it. But I think it's not clear as yet where there might be a moat. So to summarize, I think there's no obvious moat at any point in that stack as yet. Initially, I think people believed it would be just at the model level. So whoever has the best model would have the moat, and they would be so far ahead that no one else would be able to catch up. But I think the model space has become extremely competitive. So you now have multiple providers with proprietary models, you have multiple providers with open source models. You have some enterprise customers that are saying, I have enough data, I have the expertise in-house, I'm going to go and pre-train my own version of these models on proprietary data. So I think we've seen at the model level, there's actually been much more diversity than anyone expected maybe 3-4 years ago. Going a little bit above that, I think on the application layer, we're seeing some early wins, like that was the extremely popular Lensa face modification app, which was on the App Store, I think #1 for several weeks. And we've seen Jasper and other kinds of applications that have built on top of these foundation models. But even there, I think it's unclear what the end state is going to be. So for now, what we see from enterprises is they're very interested in proving out value quickly, and then they want to build the end-to-end application. And there seems to be many different options for them, open and closed. So no obvious mode where we can say, this is where all the value is going to be in generative AI. And that's a good thing in some ways, because it means that more people will get exposed to it, more people will be using it. There's going to be more competition, innovation, people trying to compare different types of modalities, different types of models. And that's what we're seeing on your side. I'd be curious if what you might have seen on the Gretel side with your customers and all the work you guys are doing in this space.
Yeah, it's a really interesting and kind of quickly evolving area. One of the things that I think the next step for what we're going to see, for at least from what we're hearing from different businesses and things like that, is given these incredible building blocks, right? Like a GPT-3 or a language model that can learn to do a variety of tasks inside of your business, right? Like, how do you take that value and apply it to that unique domain-specific knowledge that you have for your business? And that last like 80%, last 20%, so 80% of the language model and 20% kind of working with your organization's data, um, creates potentially immense value, like something that could recommend the next logical action for a patient that came in to see the doctor, things like that. So, you have the ability to reduce insurance costs. You have the ability to give better care to people and things like that. So, one of the questions we see, and one of the things I think is so interesting as these LLMs are evolving, is how do organizations put those to work? How do they use it with a really specific and incredibly valuable data? And how do they make that available to both their business? How do they make it available to customers? So exciting area.
Yeah, absolutely. And one of the themes we've seen is large enterprises have become very interested in using text as this universal interface. So one of the interesting things about these foundation models is it removes the need for a lot of expert level fine tuning of these small models, where the way you interact with the model might be that I need to create this data set, label it, then send it to an existing model like BERT, and then I get some output and I deploy that into production. And the zero shot capabilities, which as refers to the model's ability to generate accurate results without seeing new examples, that is something that widens the accessibility of these models, because anyone can basically go and give text prompts in natural language to the way you and I are talking right now and get some interesting results back. So it just widens it out. And now we're seeing not just the machine learning team at large enterprises interested, but also the HR team and the legal team and marketing. And it's just democratized it very quickly.
That's one of the areas that I think is just beginning to be understood for the applicability of LLMs, is to create interoperability between data inside of a business, right? Yeah. So whether you're looking at customer interface, chat logs that you might have, or you could be looking at metrics from your product, or even across databases. I think that's one of the promising things that we're starting to see, is that it's no longer a massively complicated SQL join that you have to do to query a couple data sets and get insights across your business. LLMs, when properly applied, have the ability to create that interoperability layer, and then a very natural kind of text interface, as you were mentioning, just to ask it questions.
Yeah.
So.
Yeah, and I think that's the big opportunity that we haven't even begun to explore, of how these LLMs will fundamentally change the way companies operate, share data, where they draw boundaries, where tribal knowledge lies and gets unlocked. All of these things I feel can fundamentally change because of LLMs.
Yeah, I think that's awesome. And we actually, in conversations with customers, have been kind of asking them, like, how do you see this data being used? One of our customers actually brought up a really a neat way to think about it, and they were talking about the generative models trained on their domain-specific data as being like the activated form of their data, in the sense that you could query it however you wanted to. You could use it to create new data sets to train machine learning models. You can send it to your business intelligence tools. So it creates a really kind of efficient, compressed version of data for your entire organization, which is really exciting.
I like that framing a lot, and it resonates with something one of the large enterprise customers said recently when they were thinking about these generative AI models. That before, we used to think about these machine learning projects where we had to take our data and bring it to the model, bring it to compute. And now the way we think about it is our data and our logs are, let's say, on AWS and S3 buckets and data lakes. And we want to bring these generative AI models to the data. So the data and all the workflows that generate that data stay where they are. And then we bring the models to the data. And I think that resonates really well with what you were saying about just activating all of that data.
That's awesome. Going back to one of the topics that you brought up earlier about the closed versus open approaches with foundation models. So, rewinding the past 5 years, we've gone from a totally, at times open approach with open data sets and open code, to open algorithms, but not open data, to a lot of things being back behind APIs right now, and anything in between. Any thoughts or any comments that you would have on that and what that means for the industry?
I think it's a rapidly evolving landscape in question, because we, as you said, we went from having almost entirely open models to having lots of closed proprietary models, and now we have open models again. And I think what we have customers and partners that are doing both, right? So we have some partnerships with customers like Stability AI that have the open source Stable Diffusion model that they contribute to. We also have some of the broader startups in the Stability AI community and ecosystem that are working on language models as well. We work very closely with Hugging Face, and they have obviously this huge repository and GitHub of machine learning models, as we describe it. But then we also have partners like Cohere and AI21 that have their own proprietary models. So I think we expect that both will coexist. I think by now we would have seen if there was a strictly open source solution here that would win. I think we should expect that there will be proprietary closed models that will likely have small advantages in accuracy, potentially in performance, because they might be ahead by 6 to 8 months or even a year to market. They might have access to some proprietary data. And in many ways, the model is not really the moat, but the data that they use might be the moat. And if you look at the accuracy benchmarks, I think these are intensely competitive. Mm-hmm. So in many ways, the open and closed question might be trumped to some extent by how you can improve on the accuracy and the instructability of these LLMs. One thing that I think is fairly clear to us now is we won't expect to see only closed models. So if you look at the two extremes, I think we see closed and open coexisting. So we don't expect only open models. And on the other extreme, we don't expect entirely closed models because there's such a strong incentive and such a strong demand and so many active communities in Discord that want to create open source alternatives. So we expect that there's going to be maybe a few closed models that show the way and have the best accuracy, the best performance. And then within a year, we expect that there would be different open source communities having kind of a version of those models with similar performance and size.
Gotcha. And when it comes to application of these models, whether open or closed, what would you say are some of the biggest roadblocks that you see across like customers or conversations that you're having, or enterprises successfully adopting and using large language models?
I think the biggest blocker is often that the zero-shot capability is good enough to prove out some concept, so do a quick MVP and get funding or buy-in internally, but it's not good enough to actually build into an application and deploy at production. So that's one. You typically have to do some amount of instruction tuning to make it adaptable to your domain, to your data. The second is that enterprise customers have a lot of requirements on their production endpoints, compliance, security, how things work within their VPC, what gets logged, what doesn't. And these are orthogonal to machine learning. These are just true for anything that gets deployed into production. So very often the POC might be successful, but then they have to actually come up with a way to deploy the model within their own environments. And those two can actually be a lot easier with open source because the model artifact and the weights of the model are available to the enterprise users, and they can then go and modify that. They can deploy it in their own VPCs and their own endpoints. So we've actually seen some cases where the closed proprietary model providers have to come up with a lot of one-off solutions, or have to come up with encryption so that they can give enterprise customers that reassurance. Now, if you're doing kind of quick experimentation, like you just want to go in ChatGPT, try something out, this stuff doesn't matter. But if you want to go and scale this up and say, I want, all of this enterprise customer and its 60 million users to be able to use this thing, the requirements change dramatically. And a lot of those requirements have nothing to do with LLMs and machine learning.
Yeah, that's one thing that, I'd say we'd see pretty often at Gretel within our user base and community as well, is that data that you're adding often is, both intellectual property, like very important to your business, but also has like really strong privacy concerns. And particularly in regulated industries, like some of the most exciting applications of LLMs that we see happening, and like the fintech, the insurance space, the life sciences research space, data sharing, things like that, are blocked, and there's a risk of what happens if a model ends up memorizing particular customer information and replaying it. Like, what if that data can be extracted from the model, or it gets memorized in a way that it shouldn't? So that's one area that we definitely have put a lot of work into, and that are also seeing coming up as a really important area, in addition to the security and the compliance risk. The putting data to work requires confidence that you're not invading on the privacy of that really sensitive customer data you have.
Definitely. I'm curious, what kind of controls or limitations have you seen customers place because of those reasons you just cited, because of privacy? Like, what do they do to mitigate that?
So across our customers, and it does definitely depend on the use case, but you see this goal of finding a balance between the accuracy of your data and the privacy. So you could create a perfectly private data set by not training it on anything and have very little utility, or you could train on the raw data and go for maximum utility of the data. What we find is really kind of looking for a balance. And what we're seeing is the application of really awesome privacy enhancing technologies being applied into the language model space, into the generative AI space, which has a lot of promise. Those approaches can either happen. One of the areas we've done a lot of research and experimentation with is actually happening during the model training phase. So it can either happen as you're training the model, and talk about how that'll work in a second, or you can really do it on the outputs of the model, and making sure that when a model is queried or it's generating data, that is not generating things that are too sensitive. So really a post-processing step. One of the most powerful privacy enhancing technologies that we've seen is differential privacy. And one of the kind of cool things that can be done is, as you are training a large language model.
So sorry, do you want to explain what that is?
Yeah, differential privacy. It's a concept actually rooted in mathematics. And it's used by the U.S. Census Bureau. It's used by, even like really large examples like Apple and Google use it with Android phones to make sure it's not, it's learning from user behavior, but it's not memorizing things about that user. And the concept is that if you have a data set, it's composed, and typically these have to be very large data sets, but it's composed of hundreds of thousands to millions of people in the U.S. Census, 350, 400 million people in the U.S. The idea is, how do we know that no individual's privacy is being compromised by a metric or a model we might share access to? And what differential privacy does is it inserts noise into a data set, inserts enough noise that you could, and this is what the metric shows, that you could remove any single user from that data set, query it with any question, and get, with a negligible difference, the same answer. And the idea being, if my data is not inside the census data set and someone queries it, and I have no impact on it, then there's no way that my privacy is compromised.
That's an awesome explanation. And we've seen cases where customers had a trained model, it was hitting the desired accuracy, and then it took like 6 months to review and get to that level of confidence. So it passes that threshold, and people can say, yes, this model is not leaking private data.
Yeah, and that's differential privacy is not without its own set of risks. And so there's other technologies that will have a lower impact on accuracy, but when it comes to absolute confidence that a patient's medical data is not going to be memorized, it's hard to beat it. One of the other neat things about this, and leveraging some really cool work that came out of the Google TensorFlow privacy team, implementing differential privacy during model training. So essentially, as data comes into the model, it goes into the optimizer. We clip the gradients on the optimizer, and really that has the effect of making sure the model can't memorize rare data, which would apply to a person, and gives you a lot of confidence there. There's other technologies that we see too. It's not everyone wants that perfect differentially private thing, or it doesn't always make sense for your data set. So other technologies we see in between, federated learning, interleaving public data with private data while you're training. All these different things can be put together. Searching for data that's too similar or too dissimilar from the training data set that came in, are all kind of neat technologies that can apply to solve privacy for these models. So maybe jumping on, let's go ahead and talk about the AI application stack. So at AWS, you have so many developers that are building on top of LLMs and things like that. And there's these lots of distinct areas. Ones that come to mind in between the model, the infrastructure, or even like the user interface that's used to query it. Where do you see opportunities coming up for innovation? Where do you see developers like really getting maximum bang for their buck on investing some time and learning how to use these different technologies?
Yeah, I'll start with an example that I personally find interesting and I struggled with. So if you use Stable Diffusion, let's say go to Stability AI's application, Dream Studio, and then you put in a prompt, you get an image back. You find that there are these modifiers like trending in ArtStation, Unreal Engine, and things like that, where you would keep adding these things to your prompt. And it gets to a point where any prompt you find in, let's say, Reddit or Twitter just has like 14 different modifiers. And no one, I think, has a good sense of, what each one of these modifiers is doing to the image. It's almost become like a ritual that you have the actual prompt of the thing that you want, and then you add these like 14, 15 modifiers to it at the end, and hope.
Don't forget negative modifiers too, also.
And negative modifiers as well. No. I think for the average user, that's a tough user experience. And prompt engineering has many different challenges, and there are people who are now just specializing and becoming really good at defining prompts to these models. But for the average user, that's going to be challenging. So I think one of the overlooked areas where there's not been enough investment, and we see huge opportunities from customers building these models or building applications on top of these models, is actually in the UI, the user interface, and how your end user interacts with the model and how they understand the way to make these models more robust, what kinds of modifications to prompts can make the image better. And there are some interesting examples where some applications now offer enhanced prompts. So you type in the prompt you want, and then it auto suggests enhancements to the prompt that might make it better. But I think it's a very complex problem, because when you give a prompt and you get something back, a text output or an image, it's in this semantic space that you can't visually understand or see in an intuitive way. Mm-hmm. So you might make one very small change to the prompt and you could get something completely different, which in your head should not be that different because the prompt itself was so similar, but that semantic space is really far apart. So I think there's a lot of opportunities to innovate in the UI to make it easier to understand the variability, to make it more robust, to make it to help people incrementally give better prompts, or to remove the notion of prompts entirely and say, we get the intent and we're just going to give you the thing that you want. We become really good at retrieving and generating based on how we perceive your intent. And one of the simple examples of that is, I think there's prompt ablation. There's a GitHub open source project, I forget the name, but it does kind of an automated prompt ablation. And I would fully expect that, some in maybe a couple of months, you might have some application that says, well, within 300 milliseconds, I'll give you the immediate result to the prompt you gave me. And then in 600 milliseconds, I'm going to give you an ablated prompt result, or 6 different ablations that remove one word or 2 words or a few phrases and then give you the result. And then by 2 seconds after you submit the prompt, you'll be able to see all of this in kind of a single UI, and you can then understand how the variability works. So things like that, I think, are really missing. And that's because we're so early. These things are happening so quickly that we haven't gotten to a lot of the UI challenges as yet. But as bigger enterprise customers start using these technologies, I think the UI will become key.
Yeah, building on that a little bit too, a very similar use case is in the RLHF space. So like reinforcement learning, human feedback. Something so important in making that work is getting a strong signal like from the users of your application, like what their preferences are, right? So if you are using reinforcement learning to fine tune your application and the responses coming back, like as we've seen happen in ChatGPT, creating an interface where you can get those preferences real time from customers, like about how well it's working for them. That's so important to the success of that model. Can really be empowered by having a good UI that makes it simple to provide that feedback.
And that connects really well with the earlier conversation, part of the conversation about data. Because if you have a good UI that allows you to capture user feedback with even a simple thumbs up, thumbs down, did this work for you? That's future training data for you. That's data you can use to tune the model for higher accuracy. So I think someone who figures out the user interface to make the usability of these models a lot better, and to figure out the hooks that allow you to feedback into the training, I think that ecosystem or flywheel can be really powerful.
So that brings us to our next topic, which is a question we hear all the time about, like, how much data sets do you need to train LLMs? And where do we see that cutting edge research? Where do we see that model parameter size versus the training data set size today? Where do we see that changing? Love to hear your thoughts on it.
So there's an interesting history here. In 2020, OpenAI published a paper on scaling laws for LLMs, and they used the GPT-3 training results to illustrate that you should increase model size more than data size. And if I remember the example correctly, if you have 10 times more compute, then you should increase the model size by 5x and the data size by 2x. And they demonstrated these power laws that seemed to hold, and it resulted in people training bigger and bigger models. So we got some 600 billion parameter models, and people were talking about trillion parameter models. And then Google had a paper about a year ago that's referred to as the chinchilla scaling laws, or chinchilla paper. And they said, actually, that might not be true. And you might want to scale the data and the model size differently, and scale the data. And the data scaling is more important than we thought. So what that's resulted in is a lot of models that are still large. So they might be tens of billions of parameters, but they can actually outperform the accuracy of bigger models because they were training on bigger data sets. So if you looked at GPT-3, I think it was trained on like 200 to 300 billion tokens. And so now we hear about customers training 100 billion parameter size models, but with 2 to 3 times the size of training data. So I think there's been a little bit of shift where the focus is now more on training large models, but not these enormous trillion parameter or 500 billion parameter models, and then just training them on more data.
And what are some of the like the effects that businesses feel when they don't have to fine tune a 200 billion parameter model? You get to fine tune instead just a 50 or 70 billion parameter model.
Well, I think one of the immediate effects is cost, because you can deploy smaller models more easily. So if you take a 50 billion parameter model, you quantize it to reduce the memory footprint. You can deploy it on cheaper accelerators, smaller accelerators, and you can then have a fleet of these machines to do inference. If you have to actually deploy a 200 or 300 billion parameter model, then you need to split that graph over multiple GPUs, multiple machines of GPUs, and that gets very expensive. The latency can be quite high. So smaller models have this huge direct benefit by making inference more cost-effective and making the latencies much more reasonable for real-time applications.
Got it. And if, for example, I'm an enterprise customer in, let's say, the precision agriculture space, just make up a space. Yeah. Should I be thinking about fine-tuning one of these large language models, or should I be thinking about training my own LLM from scratch? How do you find that difference there?
Yeah, the journey we've seen most enterprise customers take is they always begin with a pre-trained model, and they try and get a baseline and see if this is promising. And once they get that baseline from an existing pre-trained model, they might think about how they could improve upon that. Now, depending on how unique their domain is, they might be forced to pre-train. So, for example, we have a customer that was doing things in the legal space. And they had a lot of terminology from these private proprietary contracts that could just never show up in any LLM training data set. And so the vocabulary was fundamentally different. So when they tried to baseline and then even fine tune, they found that the pre-trained models just didn't contain the vocabulary that they needed. So they had to pre-train a model in their own corpus because that gave them a model that contained all of this legal vocabulary. So if you're in that situation where you think the training data might not actually represent the type of situations and prompts and images that you might see in production, then you might need to pre-train. But in most cases, instruction tuning would be much easier, more cost-effective. It wouldn't require as much compute, wouldn't require as much data, and would get you a really high level of accuracy.
That's great. So typically, get a data set, fine tune it, instruction, fine tune it, and deploy and see how your results look. And then if your data is too different, then you can take a step back and say, like, I'm going to think about training an LLM from scratch, this particular use case.
And very often, you might even know before you begin trying any of these pre-trained models how unique your data set might be. So a lot of these models are trained on sources in Wikipedia, or they might use books corpus, they might use a data set called the pile. And you can do a comparison and see what kinds of artifacts and documents are included in there, and how is that different from what you might include in your own data sets.
Some kind of interesting insights on that one too. When you think about like how diverse and different data could be. One example we had was working. Actually, it's one of the talks that we have at the conference is working with Illumina on genomic data. And interesting things that we found are that while genomic data looks radically different than anything that a typical large language model would have been trained on before, you have over 100,000 columns for each individual, each containing different correlated features and things like that. Having a model that has an understanding that, for example, had seen millions of different tables before, could add meaningful new data to support the synthetic data sets being created, even if it never seen an actual genomic report before. So it's kind of interesting insight there. But it's also a really good call out that radically different kinds of data, whether it's a different language or things like that, could require starting from scratch and training from random weights. And it's not nearly as expensive or scary perhaps as it was a couple of years ago to do that.
Yeah, and I think the recent trends have shown many cost-effective ways in which you can modify these pre-trained models. So one of the interesting approaches is using retrieval-based models. So the idea here is you have the LLM model generating text, but then you have a retrieval model that can augment the generation model and can take a corpus of documents that maybe, to use that same legal example, you have a bunch of court filings, and you want to be able to generate text to write new legal briefs and documents. So you can use the LLM augmented by this retrieval model to be able to search and retrieve relevant documents that you provide. So you can think about the benefit of this as akin to fine tuning. You're making the pre-trained model more accurate for your use case, but you don't have to actually go and change the model's parameters. You don't need to get compute and retrain the model. You just need to use these retrieval augmented architectures. So there's many interesting approaches now that I think lower the bar in terms of cost and the level of expertise needed to allow you to adapt these LLMs for your use case.
One of the really neat things to think about retrieval models as well is like the dealing with latency, right? So if you have a foundation model that's been trained on data up until 2022, but you want to ask it questions about your business or about the news or things like that it might not have been fine-tuned on yet, retrieval models open up the door for you to incorporate very recent knowledge into these models as well.
Yeah, and there's a great point there about reliability or robustness as well, because then it can cite some of the documents it used in the retrieval process. And I think U.com has a really interesting UChat application where it cites its sources, and I believe it's using a combination of LLMs and retrieval.
Yeah, so powerful. And that's one of the Other areas that we hear, a lot from customers about is like, how do we trust the outputs of the LLM? Like, how do we know that it's telling me something that's truthful, or rooted in fact, or is it just telling me what I think I want to hear, right? And so I think the ability to cite, for example, I think WebGPT kind of helped kind of pioneer some of this. U.com is doing some neat stuff there as well. We hear this as well if you are asking your, organizational LLM a question about your business. You might want to know where it got that data from. So being able to point to the data sources that it came from is a super powerful, kind of really interesting idea.
So I feel like that tees up really well. Something I'd love to hear your thoughts on is, how do you think about robustness more generally with these types of foundation models? And how can you make the models more robust, reduce the potential for harm? What are your thoughts on that?
Yeah. We think about robustness with a model in really two dimensions to start with, and then it expands into more dimensions from there. The first being accuracy, right? So given that it was trained on a data set that may have different biases inside of it, the most important thing we're doing is not introducing new biases into it. So you want to start really understanding the data you're trained on. How well did this model do learning the data it was trained on? And I think with that, I think that AI and alignment, truthfulness, and I think fairness all fit into that category for accurate data, right? It's aligning the outputs of that model with the culture and the use case for the company. So I think that's a really important part, and we talk about how that works in just a second. I think the other part there is privacy. I think often, historically, privacy has been thought of as a blocker for data, right? It's a reason that you can't access data, or you need to mask it, or drop the data. But I don't think that's the case anymore. I think privacy enhancing technologies are so good that you can view as an enabler to data and a way to access data, share it more freely, and access it and more directly. And as we were talking earlier, it's kind of finding that right mix between, accuracy for the data you're trained on, the goal you're trying to do. I can kind of dive into like how this applies to bias right now. Right now, if you look at the model card on any model that's been published, that go down there on fairness and bias, and it's going to say that this data set was trained on biased data, because all data is biased, right? You just have unwanted biases and wanted biases in there. And then the question, and really the state of the art today, is that you have your researchers or your team that are deploying this model for a particular reason, like analyze the outputs of the model and say, like, is it introducing or perpetuating any unwanted biases that we have? So it's a very manual step right now. I think one of the things that I'm personally really excited about is the idea that we could actually use LLMs to police the outputs of LLMs. So it may not always have to be this really manual process. What if through RLHF, for example, or by like a hierarchy of different LLMs, you could ensure that the output of your model kind of met the fairness requirements and the distributions that you're looking for. That raises some eyebrows when you start talking about LLMs, and you're like, wait, I thought I heard in the news that this, particular LLM could be, used to say some really kind of unwanted or biased content. And my experience working with this, and I'm curious about yours as well, is that LLMs, when you prompt them, what they're really doing is they are trying to answer the question almost in the tone that you asked it, right? So it takes on a personality of something it's seen before, and says what it thinks is the most logical answer for that.
Yeah, so it's completing the sequence.
Absolutely,
right?
Yeah. And from our initial research, and area we're spending a ton of time on right now, is saying, what if you ask it to look at the output of an LM and say, like, does this seem fair? Right? Are there certain columns in here that might introduce unwanted biases? And the initial results are very promising, and warrants a ton of research and kind of diving in, but it does kind of give us some hope that there could be some automation to detecting this like really complicated and nuanced, fairness and alignment for AI models.
I'm curious, do you think there's potential for having some kind of standardized evaluation criteria that will allow customers to say, if it passes this criteria, then I know that it's not terrible. We might need to do more, but as a baseline, I'm reassured. And I'm thinking of the paper from Stanford recently, the holistic evaluation of language models, the Helm paper.
Mhm.
And they had some interesting benchmarks. I think they have a nice website now that shows you how all the different models rank. But in your experience, especially with some of the things you've talked about around using data, using LLMs, what could that evaluation criteria be, or do you think such a standardized evaluation criteria could even exist?
Yeah. Since the first time that we created a model that could recreate tabular data like 3 years ago, right? And you created a new data set and looked at it, the very first question we got from our users was like, that looks great. Like, how accurate is it? And that's something I think that we've evolved quite a bit. I think if you look at evolution generative model space that's happened, I think it started with understanding the accuracy. So how does the distribution of outputs of this model, whether I'm using conditional or unconditional data generation, like match up against the original data it was trained on? And the second dimension that we've seen on top of there, and I think those metrics are getting pretty robust, which is really kind of exciting to see, where you see things like, how close is this to the original distribution that I had, whether using PCA or looking at some sort of dimensionality reduction technique or something like that to compare them. It's a pretty well understood problem. Privacy is the next step, right? How private is my data? And we hear about that quite a bit. And there are the mathematical guarantees you can give for differential privacy. They don't always apply. And even when they do, what we found is that our users are looking for trust but verify. So essentially, really kind of interrogating the model and attempting to extract secrets from there. So they have a sense of confidence saying, yes, I'm happy about this being shared. And I think what you were just getting to is the kind of newest and also, very important area of how to understand the alignment of the model for like the use case or the task that I'm applying it for. All these are really important. And really what we see them happening is at two different levels. Like one, you want to make sure that your model, as it's being fine tuned, is meeting those constraints or expectations you have. The second thing is after your model's deployed and it's generating data, is it hallucinating new things? Is it generating examples like what I want, ones that I can trust on? And one of the things I think that's fascinating, we've all experimented with Dolly and Stable Diffusion and things like that. You generate images, you get a couple that are great, and then you get something that's just totally weird, right? And as you think about how enterprises are going to adopt generative AI, creative applications are definitely up there. But I think at the same time, like what we see our user base doing is using it to train machine learning pipelines, for example. And you're not generating one image at a time for your machine learning pipeline. You're generating thousands of images to help your model respond to data it's never seen before. And for that to work, you have to really trust that the outputs of that model, whether it's summarizing text or it's generating new images, kind of match those expectations for the users. So I think a really other important part is like really scoring the outputs of your generative model, whether it's images, whether it is text summarizing, for example, like a post or a sales call transcript or whatever it is. You want to make sure that it's accurate, and that's a whole different class of things. We call them validators. But essentially, look at the output of each individual model and say, yes, this matches my expectations or not.
I think it also goes back to the conversation we had earlier about UI. And I think the user interface can play a big role in reducing the chance of harm and trying to improve accuracy. So a good example of this is there are things you can do at the prompt level. So if someone asks for a prompt that might be kind of malicious or looking to generate questionable content, there are things in the UI you can do that actually catches that early on, and that's not even a model issue now. And then once you get the output, I think there are things you can do within the UI to just continually get that feedback. So if you have a thumbs up, thumbs down mechanism, you can use that to feed something back. And to your point, I think we become good at building models that can classify the output of other foundation models. So the way that we've seen customers think about this that really resonates with me is we should think about building engineering systems end to end that treat this as an ongoing problem or a metric that you need to minimize. It's not a box you need to check. It's not a gate you need to go through. You need to have some kind of real-time deployment. And we've actually, to that end, been building tooling within SageMaker, our fully managed platform for machine learning, so that we can have some of these explainability, bias detection tools built into your training and your hosting endpoints.
That's, I think, for generative AI, like such a cool premise. And thinking about the integration with different like ML ops frameworks like SageMaker, Vertex, MLflow, Kubeflow, like that whole kind of ecosystem. One of the challenges that we hear from customers is even outside of or users, outside of the testing that they do, when the model's deployed, invariably the types of inputs the model get is going to change. So being able to detect that and knowing how the model is going to respond, and even using one of the things we're really excited about is using generative AI to essentially build new training sets so you can keep your models deployed longer. You could imagine, for example, you have a model that is deployed as a classifier or as a generative model that is doing some sort of sentiment analysis task. You see the data changing. And essentially, what your goals are is to keep that model deployed and keep it performing well. And one of the cool things about generative AI is if you see a shift in the type of data coming in, you can ask it to generate more data in that domain to help it respond to the types of things that it's seeing. And incorporating model monitoring, automated retraining, and things like that could shortcut massive downtime that so many people have when you have to go back to that whole data collection process.
And I'm curious to build on that. How do you gain confidence in that process? Like, if let's say you had a data scientist at a company go to an executive and say, I think we can invest and build these synthetic data sets to augment or even potentially replace retraining the model when it drifts. How do you know that's going to work beforehand? How do you get confidence in that mechanism?
Usually, when this happens, there's real money associated with it, right? So, if you are a cybersecurity company, you're detecting attacks, or you are a fintech company and you're looking for fraud, for example, right? There is real money associated with getting these predictions right or wrong. So it is definitely an iterative process. We found that running a suite of experiments, for example, with a model, using it to generate a lot of different examples, um, can both help you understand like what that shift in data is and why the model's helping, which is really kind of key to having confidence in it. But then also over time, just running like prove itself as something that should be part of the new kind of ML workflow or process. So it's an evolving area right now. But I think the relative inexpensive cost of deploying generative models to create new data sets in parallel and seeing how it performs against your existing models is a way to kind of prove that out over time. We've had really good success, initial success so far, and we're looking to, over the next year, kind of tighter integrations with different MLOps frameworks and really kind of getting this into the process that people build with.
Are there any rules of thumb? Maybe this is kind of analogous to the chinchilla discussion we had. Like, when am I approaching my limit? That if I 10x from now, I'm not going to get much more benefit.
Yeah. We see a couple different ways that people augment a data set to make it better. So if you have real world data and you're trying to make it better, really it starts same process each time: train a generative model or fine tune a generative model on there. And often when there's a class imbalance, this is an area that's particularly suited for synthetic data augmentation. So if you have fraud, to go back to earlier example, or you might only have a few examples of something bad, being able to boost those few examples and create 1,000 more, for example, can have real impact on your downstream analysis. So today it's a bit of an art, mixed science and art, but definitely a little bit more on the art side. But it is an area we see a lot of initial success in, and that we're learning and building as we go.
Awesome.
Well, thank you today, Aditya, for joining us. Awesome discussion. Super excited about both where the generative AI space is today and where it's going to go over the next year. So we'd love to welcome any questions from the audience, and thank you for the time.
Yeah, thanks so much. This was a lot of fun.